Hello, I'm Carl Wiegers, author of the book Software Development Pearls. The subtitle is Lessons from 50 Years of Software Experience. I first learned to program in Fortran in college in 1970. Since then, I've had a lot of experience with software development in many forms. In fact, 1/3 of my PhD thesis in organic chemistry was code. I moved from chemistry into full-time software development nearly 40 years ago. Since then, I've also worked as a software manager and a software quality and process improvement leader. In 1997, I started my software consulting and training company, Process Impact, through which I've provided services and products to about 150 companies and government agencies of all types. So as not to be a distraction, I'm going to leave my camera off during this presentation. In this book, I've collected 60 lessons that I've learned about many aspects of effective software development. Experience is a great teacher, but it's also an expensive and painful way to learn. You can avoid a lot of the pain by learning from those who have gone before. My goal with this book is to help you improve your software effectiveness quickly by reducing the learning curves. Today, I'm going to tell you about the structure and contents of the book. 59 of the lessons are grouped into 6 critical areas of software development. I don't cover some other important areas, such as coding, testing, and configuration management. There are plenty of other good books on those topics. The book contains 16 lessons about requirements, 6 about design, 12 on project management, 8 lessons about culture and teamwork, 8 more about software quality, and 9 lessons on software process improvement. I'm not going to cover all of the lessons in this brief presentation, but I'll show you several lessons in each of the 6 areas. Finally, lesson number 60 is about what to do next with all this knowledge. The book therefore closes with a short chapter on how to begin your journey toward more effective software development by applying selected guidance from the book to the very real challenges that you face every day. Each of the 6 subdomain topic chapters in the book is structured in the same way. First, I provide a brief introductory tutorial on the topic to give you some background for understanding the lessons. Then comes a series of first steps to get you started thinking about issues that you and your team face in that subdomain. After that is a series of essays, one on each lesson. The lessons include many true experience examples that illustrate the lesson, along with key points and descriptions of practices that you can apply in your projects to put the lesson into action. Each chapter concludes with some next steps to get you started. The first steps invite you to list the current practices in that topic area that you're good at, and also to identify problems in that area you might encounter, the impacts of those problems, and also try to think of their root causes. The next steps at the end of each chapter will help you think through how to improve your current practices to get better results. I'll ask you to think about identifying relevant lessons from the chapter, along with your own lessons from your personal experience. Then you want to identify practices that might address the problems that you came up with from the first steps work. And then also it's helpful to identify barriers you might encounter if you try to implement each of these practices. Finally, it's a good idea to think about templates, procedures, guidance documents, and other work aids you might be able to put in place to help your team members consistently apply the practices effectively. Let's start with requirements. Requirements are the foundation for all of the project work that follows. I've been interested in improving how projects handle their requirements for a long time, and I've written several books on the topic. I have 16 lessons on requirements in Software Development Pearls. Here are some that I always keep in mind. The first lesson, in fact, says if you don't get the requirements right, it doesn't matter how well you execute the rest of the project. You're likely to fail. I don't mean by this that you have to get all the requirements right at the very beginning before you start writing code. That's not realistic on most projects. Ultimately, though, a successful project requires that you understand the customer's problems and the capabilities and characteristics that a suitable solution must have. Lesson 4 says that a usage-centric approach to requirements will meet customer needs better than a feature-centric approach. I found that it works much better to focus requirements discussions not on the product and its features, but rather on the users and what they need to do with the product. From that usage-centric understanding, we can deduce the necessary product functionality. Another lesson that's particularly timely is lesson 6. Agile requirements aren't different from other requirements. People sometimes talk about agile requirements, or more appropriately, requirements for agile projects, as though they're somehow different from requirements on other projects, but I don't think they are. Developers need the same information to write the necessary code correctly, regardless of the development model being used or how you choose to represent the knowledge. If the domain of requirements is about defining problems and the characteristics that solutions must have, design is about crafting those solutions. Software design encompasses 4 major aspects: architectural design, detailed design, database design, and user experience design. All of these design aspects are subject to numerous constraints that restrict the options available to the designer. A good design must efficiently accommodate enhancement and modification. Here are some of my lessons about software design. Lesson 17 says design demands iteration, and incidentally, the same is true about requirements. I found that you just can't get the design right on the first try, so you have to plan to iterate as you explore design alternatives. Prototypes are one effective iteration technique, but it's cheaper to iterate at higher levels of abstraction. I'm a big fan of both analysis and design modeling using any of the available standard modeling notations. Please don't invent your own. By creating models, diagrams that represent various aspects of your proposed design, you can easily modify those as you get more information or new ideas that help you improve your initial design. Iteration is a key success factor for design. Another thing I've learned is that you can't optimize all desirable quality attributes. Products of all kinds have many quality characteristics, but it's impossible to simultaneously optimize all of them. These quality attributes describe not what the product does, but rather how well it does the things that it does. These kinds of non-functional requirements are a big contributor to customer satisfaction. Therefore, you need to know which attributes are most important to business success so you can focus on those during design. The 4th topic that I address in the book is project management. Now, in my opinion, project management is not a discrete discipline. Instead, project management involves managing many activities that, in the aggregate, contribute to project success. These project management activities include managing people, requirements, expectations, tasks, commitments, risks, communications, changes, resources, dependencies, contracts, and suppliers. These activities could be performed by a single individual, a group or hierarchy of managers on a large project, or collaboratively by partitioning activities among multiple team members. Here are 3 of the 12 lessons the book contains about project management. Lesson 24 suggests that we don't give anyone an estimate off the top of our heads. The best answer to a request for an estimate is, let me get back to you on that. Off-the-cuff estimates that are prepared with too little information and too little analysis are often too low, and yet they sound like a commitment to the recipient. Also, just like icebergs, projects are almost always going to be larger than they first appear. They nearly always seem to be bigger at the end than you think they're going to be when you start. Therefore, you should incorporate contingency buffers to accommodate the expected growth and also unexpected things that can happen. If you try to track the percent completion of tasks, you can think you're farther along than you really are, so I prefer to track tasks on a binary basis. A task is either entirely done or it is not done. You get no partial credit. So the way I like to do this is to break large tasks into a series of smaller tasks called inch pebbles. Get it? Not milestones, inch pebbles. And then as I'm monitoring progress, each of those small tasks is either done or it's not done. Every organization, company, department, and team has its own culture. In brief, the culture describes how do we do things around here. A healthy software culture is characterized by a set of common values and technical practices that drive the behaviors and decisions of the people in the organization. I think a healthy software engineering culture includes commitments at the individual, project team, and organizational levels to build high-quality products through the sensible application of appropriate processes and practices. And if all goes well, the team members have a good time along the way, too. Here are some lessons I've learned about culture and teamwork. Lesson number 35 says, knowledge is not zero sum. Unlike many other commodities, if I give you some of my knowledge, I still have it myself. I can use it, I can pass it along to others. And I think a healthy organization fosters a culture of free knowledge exchange and continuous learning. I don't have much patience with people who hoard their knowledge, protecting it, rather than sharing it with the other people that they work with. We're all on the same side here. Let's share what we know so we can all do better. The next lesson says, no matter how much pressure others exert, never make a commitment that you know you can't fulfill. A commitment is a promise that someone makes to perform an action or deliver some body of work in a certain quality state at a specific time. Now, we make commitments thinking most of the time that we can come through on them. And if you discover that you can't fulfill a commitment as intended, for whatever reason, it's a really good idea to tell those who are affected as soon as possible so they can adjust their plans accordingly. That's just being courteous. But to even avoid being in that situation, try not to ever make a commitment that you know at the time you're not going to be able to fulfill. Another important lesson is lesson 41. Don't underestimate the challenge of changing an organization's culture as it moves toward new ways of working. You can't change an organization's culture by issuing a decree, a policy, a bunch of new technical procedures, or sending people off to a training class. Moving to new ways of working often requires as much cultural change as technical change, but it's harder and slower to make the cultural changes. People have tried to define quality for ages, but it's elusive. I've seen many attempts at it, but I'm aware of no all-inclusive yet succinct definition that applies to software quality. And we can draw two conclusions from the many definitions of quality that I've seen. First, quality has multiple aspects. And second, quality is situational. Every project team needs to explore what quality means to its customers, how to assess it, and how to achieve it, and then communicate that understanding clearly to all project participants. Here are some lessons I've learned about software quality. First, when it comes to software quality, you can pay now or you can pay more later, often quite a lot more, in fact. The cost of correcting a defect depends on when it was introduced into the product and when someone fixed it. Fixing it early always costs less than fixing it late. Later on, it's harder to find the underlying defect that caused a problem, and more software components probably have to be modified. Requirements, designs, code, tests, and so on. And we shouldn't forget that if there are problems with our product and the customer finds them, then at that late stage, those defects have affected a lot more people than just the development team. Organizations and individuals who develop software would all love to be more productive. In many cases, rework is one of the greatest barriers to higher productivity. And I found that high quality naturally leads to higher productivity. Teams plan to get a certain amount of work done in a specific period of time, but then maybe they have to fix problems found in work they've already completed. Or maybe they have to divert some of their effort to repair a production system with defects. So a good way to boost productivity is to create high quality software from the outset so that teams can spend less time on both pre-release and post-release rework. I just hate rework, doing over something that I've already done. Lesson 48 says, strive to have a peer rather than a customer find a defect. I've always felt it was better to ask one of my professional colleagues to help me find errors in my work, rather than waiting for the customer to report a problem. And have you ever noticed that when a customer calls to report a problem, they are generally not in a good mood? So I'm a big fan of technical peer reviews. And in fact, I've written a book on this topic as well. And frankly, I would never consider working in an organization in which peer reviews We're not an intrinsic part of the culture. I think that's a real important sign of how an organization and the people in it feel about quality. Now, the sixth category in which I have lessons in this book is software process improvement, or SPI. I've never known anyone who could truthfully say, I am building software today as well as software could ever be built. And unless you can legitimately make that claim, you should always be looking for better ways to conduct your projects. That's what software process improvement is all about. The objective of SPI is to reduce the cost of developing and maintaining software products. It's not to generate a shelf full of processes and procedures. It's not to comply with the dictates of the process improvement or project management framework that's currently the most fashionable. SPI is a means to an end, the end being superior business results, however you define that. So here are some lessons I've learned from leading process improvement efforts over the past 30 years. First, watch out for management by Business Week. You might find someone who's read in a magazine or in a blog about some fabulous new technique, new approach for software development, and they say, hey, this will solve all our problems. Let's do this. So people sometimes leap to adopt the latest new development approach without really thinking about whether it's right for their situation. So before you settle on any new approach, ask yourself, what's preventing us from achieving those better results already? So do some root cause analysis to understand the problem before you choose a solution that may or may not help. Now, I have found that pain is a powerful motivator for change. And so we've got a lesson devoted to that. I don't mean artificial, externally induced pain, but the very real pain we experience from our current ways of working. Sometimes, though, that pain is not apparent to everyone who's involved. Consequently, they may not be motivated to make useful changes. So you might have to have some feedback loop so that the people who you are involving in an improvement or change initiative understand why the change is necessary to reduce the pain down the road or to reduce the pain for people in another organization besides your own. Change leaders need to explain why doing something different can reduce the pain, even if it's not immediately visible to each individual. You know, I've talked to many people who said, gee, we're being asked to do more with less. We're asked to improve our project results. Well, and when I ask, well, what's being done to enable you to do that? The answer is always nothing. And so really, unless you take the time to learn and improve, you shouldn't expect the next project to go any better than the last one. The team has to take some time to assess its previous performance periodically and look at their results so they can focus some effort on the right improvement targets. This process of reflecting on an event to learn how to handle the next one better is called a retrospective. The most important output from a retrospective is the team's commitment to making changes that will improve their work life and their project results. A retrospective on its own won't change how things go the next time. The things you learn from conducting a retrospective have to feed in to the ongoing SPI activities. So the final lesson in the book is that you can't change everything at once. No matter how many points of pain, improvement ideas, or desirable destinations you identify, people and organizations can absorb change at only a limited rate. I once knew a highly motivated 20-person project team that tackled 7 major improvement activities simultaneously. The priorities weren't clear, the resources were spread thin. So despite their enthusiasm, this team accomplished little on their change journey. That was pretty frustrating. So an important keyword in any change initiative is focus. You need to identify a small number of feasible and high impact areas to address initially, and then see them through to completion so you can get the benefits of the changes you put in place. So effective change at the individual or team or organization level requires that you honestly assess your current performance, identify problem areas, think of changes that you believe would add some value, prioritize those so you can start working on them. Now, one thing I've done personally is whenever I started a new project, I would always pick out 2 areas I wanted to get better at. They might be estimation or modeling, maybe algorithm design, unit testing, database design, or anything else. Then I would try to learn about those topics and look for opportunities to apply them on my current project. Now, the time that I spent learning about that, maybe taking a training class, maybe fumbling around trying to see how to apply a new technique and make it work for me, that's time that I wasn't spending on project work, but that's a long-term investment in not only my personal capabilities, but in the contributions I can make for the team on every project I work on from then on. Now, process improvement is a cycle, and here's a change cycle I found to be effective. We need to begin with some kind of an assessment. And the first steps that I've included in each chapter in the book ask the kinds of questions that will let you assess your current performance in a particular area. Next, we need to build an action plan. Based on our assessment, we identify actions, tools, training, other activities that we believe would address the shortcomings that we identified during assessment and hopefully lead to better results. But then comes the hard part. You actually have to implement the plan. You have to take the training or buy the tools or practice new techniques to try to see if they're going to address the problems that you've encountered on previous projects. It takes a while for the results to kick in, so we have to give them time to see an impact on our projects, and then we can verify whether the new actions that we've implemented, the new processes or practices we're applying, are giving us the improved results that we want. Then go back and do an updated assessment and move on to the next improvement area. There's always something you can do better the next time. So I hope that you've gotten some ideas from this presentation about practices that would be valuable for your personal performance and your project teams. Software Development Pearls presents 60 lessons and many technical practices that apply to a wide range of software project activities: requirements, design, project management, teamwork and culture, quality, and process improvement. I'm confident that you'll get many ideas of ways to improve your work from this book. I also hope that you'll share your own lessons learned about software development with your colleagues and be receptive to their own experiences so that we can all build better software.